Okay, my name is Frank Weber. I'm the vehicle line executive for Volt E-Flex, and therefore I'm also responsible for the Volt program. I'd like to explain to you a little bit what the Volt is all about, and also what the E-Flex propulsion and vehicle architecture is doing.
So, Frank, let's go through it piece by piece, because some people don't understand the synergy between all of this advanced technology. Would you say that the holy grail of everything would be the fuel cell vehicle?
This depends very much on the infrastructure. The reason why we have combined under E-Flex a fuel cell version and at the same time an extended range electric vehicle version is because many of the components between the fuel cell and the extended range vehicle are identical. The electric drive, the power electronics, all of those components, the brakes, the steering, and also finally the vehicle architecture are common between the two versions. Where they are fundamentally different is the way how you generate electricity in the vehicle. And this means in the case of the Volt as an extended range vehicle, you have a very large battery in the car that you charge overnight, and you can go 40 miles purely electric during the course of the day. And once the battery is depleted, we plug it in and recharge it, or a small engine will kick in and generate electricity on board and is using fuel. Now,
you know, a lot of people don't understand that, and you can tell me if I'm correct, but we were just up in the Sierra Nevadas, that's where we live in California, and we lost our electricity. So we brought a generator out, put some gasoline in it, hooked it up through our dryer, and our entire house worked again. Is that basically...
This is basically what the Volt is doing. However, what we want to avoid is, and therefore we have picked this pure electric range of 40 miles, there is an engine on board that can produce electricity anytime. But the 40-mile range will allow you to basically avoid this. And this means we have analyzed in detail driving patterns of typical customers. And we saw clearly that in most cases, and we talk about 80–90%, the engine will never go on. The people will drive purely electric because they have this 40-mile range capability. And they come home, plug it in overnight, and they go electric the next day. And therefore, what is very important that you have this little generator set on board like you have in your house to generate this electricity, because maybe sometime you don't have the opportunity to plug it in overnight, and then you go and have a normal range like you have in any other vehicle.
Because you never know when your electricity might run out.
Yes. And I think this combination is very important, because the learnings in the 90s from all the other electric vehicles, even if you do 50 or 100 miles range, there will come this point where you say, do I have access to electricity? And so what happens if you don't? It is not that you can just refuel the vehicle. And with the extended range concept that we follow with the Volt, you don't have this problem anymore. And I think this is very powerful, because it takes this anxiety that initially exists completely away.
If we use the same example as my home, PG&E powers my home all the time, and they do a good job of it, except for when the miles are at 75 miles an hour wind. What happens with your PG&E, with your electric, your lithium-ion battery? How close are you to being that great of a provider on the lithium-ion battery side?
Yeah, what we have pre-selected for a development of those lithium-ion batteries with two suppliers. And this is US-based A123 and then Korean LG Chem. We are working on a unique and new chemistry as an application in the Volt vehicle. We have already received the first packs, and the packs deliver actually the power and energy level that we are expecting. And so what we see that our initial goal of having 40 miles electric range can be met with the package constraints that you have in a compact vehicle. So we are very confident that this battery and the lithium-ion technology can do what we want in our vehicle. Now what we have ahead of us is the challenges of, I would call, it's no scientific or it's no experiment anymore that we are going through. It's now the hard engineering work to make it durable and reliable, having it available under various temperature scenarios. So this is the work that we have to go through. But there is a very high confidence about the overall concept and the capability of those batteries.
Does it truly still appear that 2010 could be the date that you have production vehicles for plug-in hybrid electric vehicles?
This is currently the goal for the team. We are very aggressive on the timing and the intensity with which we work the Volt program. And what we always said is we are working the battery program and the vehicle program simultaneously. And if the battery pack works out as predicted, there is a good chance that we will meet this goal. If there are things that we will run into during the development, which can happen, we have to see and maybe adjust our timing. But currently there is no indication that we have to do this, and we are really confident that the technology can move this.
Frank Weber, thank you very much.
Thank you.